Hello everyone, welcome back to this lecture series of operating system, and the topic today will be inter-process communication. It is again a topic from the second unit of your AKTU syllabus, and we'll go with that. So the contents to be discussed today will be discussing what an inter-process communication is, and then we'll be taking some questions which are related to implementation of IPC, which needs to be answered before implementing any inter-process communication. And then we'll discuss the two types of inter-process communication, that is direct communication and indirect communication. And then we'll be discussing about a special construct of IPC, that is buffering. So we start with the definition of an inter-process communication. So what an IPC or inter-process communication is a mechanism for process to communicate and to synchronize their actions. So whenever we are having a system or a computer system in which there are n number of processes which are executing concurrently or in a cooperating manner, then these processes needs to communicate with each other because they are cooperating with each other. Therefore, they need to communicate with each other. Not only processes on a single computer, the processes on different computers on a LAN or internet, they also need to communicate with each other, and therefore we need this special construct called inter-process communication, or we need a mechanism, a predefined mechanism which could standardize the communication between these processes either on the same system or on different system located globally. So we need a mechanism for to enable these processes to communicate with each other and also to synchronize their actions. All of the actions, they should be synchronized. So in this IPC, the main constructs or the main uh, definitions we need to know is, the first one is the message system. So a message system is a system which processes through which the different processes communicate with each other without restoring to shared variable. So they don't need to resort to shared variables, but they pass some communication messages between each other through message system. So the IPC or inter-process facility, it facilitates the processes by providing two operations. The first operation is send message and the second operation is receive message. So whenever two process P1 and P2 are communicating with each other, so if P1 wants to send a message, it will call this send operation and it will pass the message to be communicated to the other process. A process wanting to receive a message will call this receive operation, and therefore these two facilities or these three two operations uh, helps a lot in inter-process communication. So how does this communication takes place? So if P and Q are the processes which wish to communicate with each other, so what they have to do is they have to establish a communication link between them. So whenever P and Q wants to communicate with each other, they need to establish a communication link between them, and then they exchange messages via these communication links with the help of send and receive operation. So they will be using this communication link, and they will use send and receive operations to send messages and receive messages through this communication link. And how the communication link is implemented? It is implemented at physical level through shared memories or hardware buses, and logical level at through different logical properties. So whenever a process, the main thing is that whenever a process wants to communicate uh, with other process, what it has to do, it has to first establish a link between them, and once the link is established, on this link the processes can send or receive messages to establish the communication. So after knowing about IPC, Every IPC implementation needs to answer few questions, and these questions will define what type of IPC we are using. So the first question which IPC needs to be answered is, how are links established? Then we'll be discussing, can a link be associated with other more than two processes or not? Then how many links can be there between every pair of communicating process? What is the capacity of a link? Is the size of a message that the link can accommodate fixed or variable? And then, is a link unidirectional or bidirectional? So on all these properties, we can decide what type of IPC we are using. So depending upon the send and receive operations and the answers to implement the questions uh, in the questions, we can decide whether a given IPC or a communication is a direct communication or a indirect communication. So in case of direct communication, the processes, they communicate by sending message directly and receiving message directly. So if P wants to say, uh, a process wants to send some message to the process P, so every process should name the receiver. The sender should name the receiver should name the the sender. So whenever suppose a process Q wants to send a message to process P, so it will means whenever Q wants to send a message to process P, so what will happen? Q will call this send P comma message. So what is Q doing? Q is mentioning the name of the receiver here, and it is also sending the message to be sent. Now at the receiver end, at the receiver end, what and the receiver will do, the receiver will call or receive Q comma message. So here also the receiver is receiving the receiver is receiving the message, but it is also naming from where the message has to come. So if P wants to receive the message sent by Q, it should call receive Q comma message. That means P is calling that I want to receive a message which was sent by Q. So this is how a direct communication occurs. So in this direct communication, what happens is every process, whether the sender or the receiver, they need to mention the name of the process. If the sender is sending a message, so it has to name the name of the receiver, and if the receiver wants to receive a message, it has to name the name of the sender. And then the properties of what are the various properties of a communication link in case of indirect communication? The links are established automatically. So in case of indirect communication, we don't need to establish the link. Once a message is sent by the sender and it is received by the receiver, the link is automatically established. Now the link associated with exactly one pair of communicating process. So in case of direct communication, and the link has to be established exactly with exactly one pair of communicating process. That means the same link cannot be used by different processes. If P and Q have established the communication link, then this link can only be used by P and Q. And then there are also a requirement that each pair, between each pair, there exists exactly one link. So P and Q can have exactly one link, and they cannot have more than one link between them. And then the link can be unidirectional or it can be bidirectional. So a unidirectional is a link in which a message has to be can be sent in one direction only. So if P and Q are two processes, and we are having a channel such that a message can only flow from P towards Q. That means this channel is a unidirectional channel because it can carry message only from P to Q, not from Q to P. So in case of unidirectional, every two process will need to establish two channels or two communication links like this, one for sending message from P to Q and another from for sending message from Q to P. But in case of bidirectional link, the message can be sent in both directions on the same link. So one link established between P and Q can carry the message from P towards Q as well as message from Q towards P. So this is what a bidirect. So in case of direct communication, the the in case of direct communication, the link can be a unidirectional or it can also be a bidirectional depending upon the situation. So the next is indirect communication. So now in indirect communication, instead of sending a message or receiving a message directly to the sender or from the sender, the messages are not sent directly between processes. What happens, the messages are directed and received from mailboxes. So every two processes will be having a mailbox between them, and whenever a process wants to send a message to another process, it will simply create use this mailbox to send the message. The receiver will receive its message from the mailbox only. So what are the requirement is, every mailbox will have a unique ID. So every mailbox created will have a unique ID. The process can communicate only if they shared a mailbox. So now, earlier we also discussed that any process P1 and P and Q wanting to communicate with each other should establish a link. So in case of direct communication, they have to establish a link. In indirect communication, they also establish a link, but this link is established through a mailbox. Suppose MB is a mailbox. So whenever P wants to send a message, it will send to the mailbox MB, and Q will receive the message from the mailbox MB. So this MB or mailbox is having a unique ID, and this unique ID is used from by the process P and Q to means communicate. Now P and Q can communicate only if they are having a shared mailbox between them. So every process cannot communicate with each other. The only those processes which have a shared mailbox can communicate with each other. So what are the properties of this link established? The link is established only if processes shared a common mailbox. So if two processes are not sharing a mailbox, there is no link between them. So whenever a process wants to communicate with another process, it has to create a shared mailbox and hence establish the link. A link may be associated with many processes. Now here it is not mandatory that a mailbox created between P and Q can only be shared by P and Q. There can be another process, sorry, R, which is again sharing the same mailbox. So a link, therefore, a single link can be used by different processes, more than two processes, to communicate with each other. So each pair of process may share several communication links, and it is not mandatory that two processes can have only one mailbox. Two processes can have a number of mailboxes between them, and therefore they can have a number of communication links between them, and these links may be unidirectional or bidirectional. So in this case, this mailbox is being used to communicate, and suppose P creates this mailbox and says that Q can only receive mailbox from this mailbox, or R can only receive messages from this mailbox. So this mailbox link becomes a unidirectional link. That means P will only send messages to the mailbox and other processes can only receive messages from the mailbox. So it becomes a unidirectional. And if the implementation is such that this mailbox can be used by either of these processes to send as well as receive messages from this mailbox, then this link becomes a bidirectional link. Now, how this communication, indirect communication, takes place? First thing is that a new mailbox is created. Then the processes send and receive messages through this mailbox, and after the communication is complete, the mailbox is destroyed. So every time a communication is needed between two processes, the processes, they need to agree upon a shared mailbox, and then these processes communicate by sending and receiving messages to and from this shared mailbox. And after the communication is complete, the mailbox is destroyed. So the mailbox sharing process P1, P2, and P3, they shared a mailbox A. Now, what happens? P1 sends, then therefore P2 and P3 will receive from the mailbox. So, who gets the message? So, we have to decide what happens. Suppose there is a mailbox shared between three processes P1, P2, and P3, and suppose P1 sends a message and P2 and P3 receive the message. So we have to decide who will get the message from there. So what is the solution? We need to decide. Obviously, maybe P1 was intending only to send the message to P2, but since the mailbox is shared between all of these three, therefore P3 can also receive the message, but P1 does not intend or does not want P3 to see the message. So how we are going to decide whether the intended receiver should only receive the message? So first solution is we allow a link to be associated with at most two processes. So we want to restrict that, though we are using mailbox, we want to restrict the sharing of this mailbox only between two processes. This is the first solution. The second solution is allow only one process at a time to execute a receive operation. So this is another solution. So at the same time, we do not allow P2 and P3 to execute a receive operation, but we allow one process to execute this receive operation, and then allow the system to select arbitrarily the receiver. Sender is notified who the receiver was. So these are the various solutions through which we can decide who will receive the message sent by any process through mailbox. So now another important concept of this interprocess communication is the concept of buffering. So what is buffering? So what we have to do is just try to understand one thing, that I am having a process P and I am having a process Q, and they have a communication channel between them, and I assume that this communication link is a bidirectional link. That means we can send and receive messages from both direction. So in spite of, suppose a P wants to send a message to Q and the message was sent directly to Q, but at that time Q was not able to receive because it was engaged in some other messages, and therefore since Q did not receive the message sent by P will be means discarded. So here it is a message loss. So another solution for the best solution for this is that we create a buffer in the communication link. Buffer means we create a temporary storage in the communication link, so that if P is sending a message, that message is stored in this buffer, and when Q is ready to receive the message, it can receive the message from the buffer. So this size of the buffer can be different with different cases, and therefore this the process of storing and forwarding a message from a receiver to a sender to a receiver is called a buffering. And this buffering, it can be implemented in three ways. One is zero capacity buffer, another one is bounded capacity buffer, and next one is unbounded capacity buffer. So in case of zero capacity buffer, it is just a communication link without a buffer. That means once the P has is intended to send the message, Q should be ready to receive the message. Because if Q fails to receive the message will be discarded, because there is no storage space on the link, and therefore it needs to be synchronized. The send and receive messages between the processes, they need to be synchronized in a manner that P sends a message only if Q is receiving or ready to receive the message. The next one is uh, The third one is second one is bounded capacity buffer. So in this case, P and Q have a link which has a buffer of fixed size. That means a buffer of n size can store n messages only. So in this case, P and Q must synchronize each other uh, such that if there is already n messages in the buffer, P should stop uh, sending any message, and if the buffer is empty, you should stop receiving any message. So it is if you remember, it is an analogy to means producer consumer problem. So we can use semaphores to synchronize the process of sending and receiving message between P and Q, where P acts as the sender acts as a producer, and the receiver acts as a consumer. And then the last one is unbounded capacity, in which the size of the buffer is infinite. That means uh, any number of messages can be stored, and therefore in this case we do not need to synchronize the actions of P and Q, because P can send as many messages as it wants, and all of them will be stored in the buffer, and then Q can start receiving the messages from that. So this is all for today. About inter-process communication. I hope you enjoyed this lecture, and I would request you to like, share, and subscribe to my channel. Thank you very much. Have a nice day.